Assalamualaikum. We are from Group 4. Today we are going to present heat transfer application. So our team members is Juliana, me, Shamimi and Muhammad Hadri. So the first heat transfer application on daily life is a rice cooker. Our group choose a rice cooker. So a rice cooker is an automated kitchen or cooking appliance designed to boil or steam rice. So the rice cooker is not only for cooking purpose, it can also be used to heat the rice. The rice cooker works by transferring heat in the means of thermal conduction. The substances itself does not flow, rather than heat is transferred internally by vibration of atoms and molecules. The basic of rice cooker consists of the main body, inner cooking pan, electric heating plate, thermal sensing device and the button. So at the right show the diagram of the basic rice cooker. So the cooking bowl, heat source and the thermostat will work together to produce the rice. Okay, next the process inside the rice cooker. The first one is the way of the inner cooking pan that we fill the water and the rice will push down the thermal sensing device while the heating plate brings the water to a boil. The heater start to heating the bowl which conduct the heat to the water and the rice. The next process is the boiling process. The heat is carried off in the steam that rises from the bowl. So the temperature of the rice at the bottom of the bowl will not go much higher than 100 degrees Celsius. At this point also, the heater will heat the water first because in that pan the mixture is mainly water. The next process is absorbing water. The rice is now absorbing the water, which is making the starch in the rice. The starch is a sugar, a bond with the hydrogen in the water. Then when the rice is absorb all the water, the heater in the pumping, the heater will still heating the pumping heat into bowl along the rice. Then but it will not lose any water left, so the temperature of the bowl will quickly rise. The next process is the resting process. The sudden temperature bump triggers the mechanism inside the rice cooker to turn the heat down or off because the rice is done. After the rice is fully cooked, the rice cooker will turn the sensor to heating state only. Okay, next is the basic principle of the rice cooker. The first diagram is the switch is not connected, and the second diagram is the switch is connected to the heater. When the switch is connected, the heater will start to heat, and the temperature and the pressure also will increase to cook the rice quickly. And as we can see also, the lever move to upward to make the magnetic bimetal and the heater connect. Then the rice cooker knows when the rice is done when the internal temperature inside the cooker reach the appropriate set point. The magnetic bimetal or the thermostat move the lever downward, thus the switch is disconnected. This is at this state we call it as the warming state. Okay, thank you.
Okay, so I will continue for the rice cooker calculation. So as we can see from this slide, we use this equation. The first equation is QH equals to P times time taken. So the QH is the heat that produced by the rice by the thermal heater in the rice cooker. So we assume that the fixed power for the rice cooker is 500 watts. So it is like the it it is based on the what type of rice cooker we use. But this one we fix the power is 500 watt. So and then we assume that the metal pot instantly transfer the heat to the water, and that does the heat absorb, so that the heat absorbed by the water will elevate its temperature. So and then we assume that the temperature is uniform in the water, so that the temperature while the water is not boiling is written as the equation below. So this is the second equation. So the second equation is TW equals to T0 plus QH per divide by QPM. So QP is the specific heat capacity. So we use the specific heat capacity of water, which is 4.2 kilojoule per kilogram dot Kelvin. So this specific heat capacity is used to raise the temperature of a kilogram of water by 1 degree. So we need to transfer it for 4,200 joules. So, and then when the water reach 100 degrees Celsius at atmospheric pressure, it will begin to boil. So the boil process is when water turn from a liquid to a gas. So this process require a lot more energy than the heating process. So when this process occurred, we will assume the evaporation in delta H evaporation equals to 2257 kilojoule per kilogram. So once it become gas, the water mix with the air in the rice cooker atmosphere. At the same time, a flood of outgoing hot air and water gas appears. So this is the basic knowledge for the rice cooker calculation. So this is the example for the calculation. So I assume that the power is 100 watt as the previous slide. So the time taken is 300 minutes with 30 minutes which is equals to 1800 second. So the mass is 0.75 kilogram and the temperature is 100 degrees Celsius. So using the first equation, QH equals to power time second. So we get the QH, which is the heat, 900,000 joules. So and then we using the second equation, TW. So using this equation, we calculate and write in the the value, and we get 385 degrees Celsius. And then, so if the temperature is more than 100, we have to find the delta Q. So when we calculate the delta Q, we can see that the QH and the delta Q is equal. So after that, we find the mass of the water, and by using this water and by using the delta heat evaporation just now, and we get the mass is 0.35 kilogram. So next slide. Okay, so I will continue for the next application, which is the the heat exchanger in industry. So we choose this one heat exchanger, which is rubber glove heat exchanger. So this is the air plating heat exchanger radiator for the rubber glove. This is the one of the industry manufacturing application. So as you can see from the figure, this is the heat exchanger for the rubber glove. So next slide, please. Okay, so there are many type of material for the heat exchanger. So as you can see from the figure above, you can see that there are many type of tube and fin. So um, so the type of material that used for the tube is copper, aluminium, carbon steel, and stainless steel. And for the fin, aluminium and steel. And for the processing technology for this heat exchanger is cream fin type, extrude aluminium fin type, aluminium nest plate type. So the medium that are used for this heat exchanger is hot water, cold water, thermal oil, steam, also and etc. So there are many type of medium. So I will pass to Hadi for the next slide.
Okay, thank you, Anna. So I'm explaining about the heat exchanger. Okay, so before I'm explaining about heat exchanger, I will briefly go through the glove manufacturing process. So that we can see clearly in which part of the process in glove heat exchanger will be used. Okay, so here are the process. It will start with raw material test, compounding, dipping, leaching, striping, quality control, and packing. Okay, so basically after the latex mixture is right, which is in the dipping process, so the glove are passed through a leaching line, which is to remove any remaining chemicals or proteins from the glove surface. Okay, so the leaching line is actually a long process because that it will allow the latex protein to be washed off more effectively. Okay, so to dissolve the proteins more effectively, the water should be hot and fresh. Okay, so this is where the heat exchanger will be used. So basically, heat exchanger are functioning in recover useful and valuable heat. I mean like the heat that wasted from the leaching process. Okay, so before I explain about the okay, so before that I will explain about the heat exchanger. Next slide. Next slide. Okay. So heat exchanger is a system used to transfer heat between two or more fluids, and heat exchanger are used in cooling and heating process both. Okay, so the fluid may be separated by a solid wall to prevent the mixing or indirect contact. Okay, so here is the basic principle of the heat exchanger. We can see that the blue arrow is indicate that the cold fluid, and the red arrow is indicate hot fluid. So this is the flow of the fluid in the heat exchanger. Okay, so in this case, which is I mean in the glove industry in Malaysia, series plate heat exchanger were installed to recover the heat from the leaching process actually. Okay, so this was then used to preheat the fresh water used for washing in the leaching tanks from 30 degrees Celsius to 60 degrees Celsius. So basically the 30 degrees Celsius temperature rise actually utilizing recovered heat and have a working capacity of 9,700 liters per hour. And this means that the high efficiency unit is able to recover roughly around 466 kilowatt of energy each hour, and resulting in a 4 months payback period from gas saving. So it is worth it actually to install heat exchanger in the glove industry. Next. Okay, so here are the heat exchanger calculation. So we consider a parallel flow heat exchanger, and we want to calculate the logarithmic mean temperature difference and determine the area of this heat exchanger required for this performance. So as we can see in the question here, so we need to find LMTD. So first of all, we need to jot it down the formula of LMTD, which is LMTD equal to delta T1 minus delta T2 over ln delta T1 over delta T2. So we just plug in the information from the question, and then we got LMTD is equal to 14.91 degrees Celsius. And then if we want to find the area, we just use formula Q equal U times A times LMTD. So we reconstruct it again, the formula to find the area, and it will become area equal Q over U times LMTD. So LMTD here, we already get it from the above equation, and U from the question given, and we need to find Q. So how to find Q? We just use formula Q equal M dot times C times delta T. So we get it 144 kilowatt. Okay, so we just plug it all the information, and then the area of heat exchanger required for this performance is 9.66 meters square. Okay. So I think that's all for our presentation for heat exchanger. Okay, so thank you.